So in this video, we're manipulating the indices to solve for x. So we're using everything we've used in the last two exercises, but we're just going one step further. So how do we find what the original x was? So we need to do the reverse, in a sense, of what we have in front of us. So, where to begin? At the moment, you have x to the minus 2 by 3 equals 4. And you know what that minus means. That minus means 1 over. So this is the same as 1 over x to the 2 by 3 equals 4. So if we're trying to make x the subject, we're trying to get x equals, how can we do that? It might be a good idea then to times, we don't really like fractions because we're trying to get x by itself, we'll times up by x to the 2 over 3. So at the moment we have 1 equals 4x to the 2 by 3. We can divide by 4 then to get x by itself. So x to the 2 by 3 is 1 over 4. And we know that x has been squared, right? So how do we get the opposite of that? Well, we need to square root both sides. So can you see if we square root the left, then we can square root the right to get rid of that 2. Because square rooting, as we know from the previous video, is the same as raising both sides to the power of a half, okay? And you know that a to the x times, to the power of y, sorry, is the same as a to the x times y. So these powers are timesing each other. So if I do something to the left, I have to do it to the right. So this is x to the third now, equals, and then the square root of a quarter is a half. But because I've square rooted both sides, because remember the square root of a quarter, that's the square root of the top over the square root of the bottom, okay? Because I've done it to both sides, I need to do a plus or minus, because both minus a half and a half could be x at this point. They would both, if I square a half and if I square minus a half, I would get a quarter, okay? And then finally, we want to get rid of this cubed on the bottom. So to get rid of the cubed on the bottom, we need to do the opposite. So the cube root, if I've cube rooted something, I need to cube both sides to get rid of that 3 on the bottom here. So that becomes x to the 1, perfect, because that's 1 over 1. And then you've got plus or minus still, and then a half to the power of 3. So that's the same as 1 to the power of 3 over 2 to the power of 3. So that is 1 over 8. Okay, done. Let's have another go. So 3x to the 5 by 2 over 96. So we're trying to get x by itself. So the first thing to do is probably to divide by 3. So this would be 32. So 96 divided by 3 is 32. And then it's always better to reduce things rather than make things bigger. It's always easier to reduce things first. So you can see that 5 on the top, x has been raised to the power of 5. So like we did earlier, we need to do the opposite. So to both sides, we're going to fifth root, which remember is the same as raising something to the power of 1 over 5. Okay, so this is x to the power times power, right? So 5 over 2 times by a fifth is a half. And then 32 to the power of a fifth is 2, because remember this is the same as fifth root of 32. What do you times by itself 5 times to make 32? Well, it's got to be 2. And then finally we have the 2 on the bottom. So it's, x is being square rooted, remember? So you need to do the opposite to get it back. We need to square both sides to get x to the 1 by itself. So there's x to the x equals 4. Done. And then here we've got x to the minus 3. So we have a minus here, and we know that means 1 over. So that's 1 over x cubed is 1 over 8. Just like in example A, we could times up by the x cubed. So I'm doing everything slowly at the moment because, you know, obviously need to take one step at a time. And when you get more experience, you kind of are able to skip more steps, okay? But for now, let's get the basics right. So here, x cubed has been divided by 8, so we don't want things on the bottom. We don't like fractions because we're trying to get x equals by itself, so we times everything by 8. So at the moment we have x cubed equals 8, and therefore if x is being cubed, we need to do the opposite, and we need to cube root. So we need to raise both sides to the power of 1 over 3. So that becomes x by itself equals 2. Done. End of video.